The next supply chain bottleneck won't be chips. It will be minerals, lithium, copper, nickel, rare earths, not because the world is running out overnight, but because demand is rising faster than the system can expand. And unlike software, you can't scale minerals with a download. You have to dig, refine, transport, and process. That takes time, it takes permits, it takes capital, and it takes geopolitical stability. This is why critical minerals are becoming the next strategic leverage point in the global economy. For years, supply chain power was about manufacturing. Who can build the factory? Who controls the component? Who owns the IP? Now the bottleneck is moving upstream, toward inputs. Because electrification is real. AI infrastructure is expanding. Energy storage is scaling. And modern defense and industrial systems all depend on the same physical materials. So the question isn't whether minerals matter. The question is who controls them, and who can scale them fast enough. Let's start with the most overlooked mineral in the story, copper. Copper is the metal of electrification. Power grids need it. Electric vehicles need it. Renewable infrastructure needs it. Data centers need it. And the more electricity you produce and move, the more copper you require. The world can talk about AI, chips, and software all day, but electricity is the foundation, and copper is the wiring of that foundation. So when you hear energy transition or grid build-out, think copper demand. Then there's lithium and nickel. Lithium is central to most battery supply chains. Nickel improves energy density in many battery chemistries. Even if technology evolves, the broad direction is the same. Storage demand is increasing. And storage is not a niche anymore. It's becoming core infrastructure. Now add rare earth elements. Rare earths are used in permanent magnets, critical in EV motors, wind turbines, and certain defense systems. The issue isn't only mining, it's refining. And refining is where concentration creates leverage. That's the core of the critical minerals problem. Most people assume mining is the bottleneck, but in many cases, the bottleneck is midstream processing. Refining, separation, chemical processing, the steps that turn raw material into usable industrial inputs. This is where the supply chain is vulnerable, because it is easier to find a deposit than it is to build a full processing ecosystem. And processing is where politics, environmental regulation, and industrial policy collide. So critical minerals become strategic because they sit at the intersection of three forces: rising demand, slow supply response, and concentrated processing capacity. That combination creates pricing power and leverage. Now let's talk about the timeline problem. Even if a country wants to increase mineral supply, it takes years. Exploration, permitting, financing, construction, then production ramps, then processing is built, then logistics are optimized. This is why mineral supply tends to lag demand. When supply lags demand, prices spike. But the bigger story isn't price spikes, it's fragility. Because if supply chains are concentrated, a disruption in one region can ripple globally. A new regulation, a conflict, a sanctions regime, a shipping disruption, a political decision. Any of these can tighten supply. And in a high-demand environment, small disruptions can create big price moves. That's why minerals are becoming geopolitical. Countries are beginning to treat them like strategic assets, securing supply agreements, supporting domestic mining, subsidizing processing facilities, building stockpiles, creating alliances and friend-shoring networks. Because if you don't control inputs, you don't control outcomes. Now here's where the bottleneck becomes a true economic story. Critical minerals don't just affect one sector, they affect multiple sectors simultaneously. If mineral prices rise, EV costs rise, grid costs rise, battery costs rise, renewable build-out costs rise, defense procurement costs rise, and infrastructure costs rise. So minerals are a cost layer that can influence inflation, investment cycles, and the speed of the energy transition. This creates a policy dilemma. Governments want faster electrification and more domestic manufacturing. Electrification increases mineral demand. Domestic manufacturing increases mineral demand. And if mineral supply can't keep up, costs rise. So mineral constraints can slow the transition, not through ideology, but through physics and economics. Now, who wins in a minerals-constrained world? The first winners are countries with resources and stable permitting environments. Not just who has minerals underground, but who can actually produce them. The second winners are countries and companies that control refining and processing, because refining is where the choke points are. The third winners are countries that build diversified supply chains early. They sign long-term agreements. They invest in processing. They build redundancy. and they reduce single point of failure risk. The losers are those that assume minerals are just commodities that will always be available at stable prices. Because in a strategic world, commodities become instruments. Leverage is created by bottlenecks, and bottlenecks are created by concentration. This is why critical minerals are starting to look like semiconductors. Not identical, but similar in structure. Choke points, industrial policy, strategic competition, and long-cycle investment. Now, what should you watch if you want to track the mineral story? First, major processing investments, new refineries, new separation facilities, new chemical plants. That's where real de-risking happens. Second, long-term supply agreements. When automakers or governments lock in supply deals, it signals scarcity anxiety. Third, export restrictions. When a country limits exports of a key material, it's not just a trade policy move, it's leverage. Fourth, permitting and local politics. If major projects are delayed, the supply response weakens. And fifth, substitution and innovation. If battery chemistries shift away from certain minerals, demand patterns change. But substitutions take time. And scaling new chemistries takes time too. So the near-term story is still about physical constraints. The long-term story is about who builds resilient supply chains. The takeaway is simple. In the next decade, critical minerals are not just inputs. They are strategic infrastructure. They shape the cost and speed of electrification. They shape the competitiveness of manufacturing. And they create new geopolitical leverage points. The chip war taught the world that controlling key inputs controls outcomes. The minerals era will teach the same lesson, upstream. Because whoever secures minerals and processing capacity secures the ability to build. And in the next decade, the ability to build is power.